And to start with, we would be starting off with another presentation by a young person. In fact, I would say they are also one of our partners. It's from Globcity. So to begin with the session, we would like to call upon stage Mr. Sanket Saran, founder and director from Globcity, to take forward the session with his presentation on the next generation database, going no query. Mr. Sanket, I'd like to welcome you on stage to take it further.
Good morning, everyone.
Good morning.
Can you all hear me? So, I came in here and I was tasked with the job of waking you all up. Okay, so I hope I do it very well. So, what I'm here to talk about is nothing of what you have heard yesterday or have heard before. Okay, it's a completely new technology that Globcity has developed, which mostly I have written. And it was conceptualized 3 years ago, and it's in production today. And I'm here to talk about what are the futures of the big data industry, how it's changing, what are the generations of databases that have come, and where are we headed today. Okay. So, to basically understand what we have done in terms of changing the architecture of systems completely, you will have to forget how existing systems work. Okay? So let's have a look at how databases have evolved. So the first generation, as I would say, was SQL databases. There were a few before this, but the major databases were SQL, which were widely used, adopted in the industry, and even today are widely used for most relational systems. Right? Then came NoSQL, which was flat file databases, did not support relations. You couldn't do many things that SQL could do, but still people used it because they performed better than SQL. Right? Even today, quite a few of us over here in the big data domain use NoSQL databases. Why? Simply because they perform. No query has gone one stage beyond SQL and NoSQL. It's far ahead of what NoSQL can give. Okay? It gives you everything that SQL today supports. So it's no compromise on features, but gain in performance. So how we have done it is a complete different architecture which I will be discussing today. So what is no query? Can anyone make a guess? Anyone? Of course not my colleagues back there, yes. Anyone? Okay, it's one way. So what comes to your mind first? Okay, perfect. So in other words, let's put it as an ORM layer, right? Object relation mapping layer, which doesn't take queries. Now, if I was sitting in your place, I would have actually thrown tomatoes on the stage, right? Because I'm saying we build a next generation database, and I'm here to talk about an ORM layer. Okay, of course, that's not what I'm going to talk about. Right? What you mean by no query as an ORM is perfect. Right? That's where we got the name from. We built the database. When we built it, we made sure that we made an adapter to it, which was an ORM layer, and it did not take queries. Unlike most common adapters, like if you take a Java adapter, you will have JPQL, some type of query that you need to write. Our ORM apparently doesn't require queries. You can just do load, inserts, updates directly on business objects, and the business objects are exposed straight out from the database into the app. That's how we got the name. But this is not what we sell, and this is not what I would term as a next generation database. So let's look at traditional database architecture. If you see, you will always have a client who uses your app. I'm considering a web client here because most of the development today happens across the web. Over HTTP is what your clients do, right? Even if you're doing application deployments over a WAN network, your still clients are over HTTP today, right? So your client communicates with the app with TCP or HTTP, as you would say. Your application communicates with the database via a TCP channel again, right? All agree? Correct. Why do you think you had to do this? Can anyone give me an example of an application that does not require data storage? Anyone? I've been a consultant in many firms, but I've never seen an app that doesn't require data storage. No matter what, you will say it's just a processing app, you will still have some constants or something that you will want to save, right? Most of the apps today require data storage. Then why is it that none of the application hosting platforms support data storage today? You will say that's not true because you can store data from any platform, but the database and platform are two separate items. You are saying I need to communicate, although my database and my platform are usually on the same server, I need a TCP link to connect between them, similar to how my user would want to connect to my application, right? It simply doesn't make sense. When you are on the same machine, why can you not access it directly? Why can the platform not have data storage capabilities? You all agree? Right? This is what we have done. Data storage is bundled as part of our platform. Now the platform that we are using is simply Java EE, Java Enterprise Edition. So anyone who is using any Java app or hosting a Java app can actually consume our database, integrate it into the platform itself, and deploy on any standard Java EE compliant server. So it's a whole new architecture. Now you will say, what are the benefits of doing this? Right? Now there are several benefits. But before going to it, let me brief you about what happens is basically how we actually came up with this concept. So to start with, when I was out of college, we actually had the idea of building a social network. Okay, and it wasn't a social network. Twitter was just picking up at that time, was barely reaching a million, had crossed a million mark, right? Facebook was there in the market, I think it was at 300 million, 500 million users, something of that sort. And what we wanted to build was, we wanted to create a social integration suite, which could integrate data from all social networks, collected into one view, and show it, right? To build such an application, the data flow is so intensive. Right? Facebook was using Cassandra back then, which they built, and they built it for reasons of scaling up. But it only scaled up to the extent that Facebook could manage. They had to move eventually to HBase. But to build an application that took data from all databases, all social networks, we needed a database which was really powerful. Right? So that's how we started writing our own database engine. And we said we want to make sure that we basically overcome all the flaws of performance that were there in existing databases. So we took all the databases, studied them, saw what performance they were giving, and eventually came out with building our own database. And we did not want to write queries for querying the database, so we made sure that our ORM layer was no query. That's where we got the name from, and eventually we made sure that our database performs so well, right? To gain the performance, we actually merged the application hosting platform and the database, right? Now, what happened to the social network? By the time we built this, the fad of the social network had passed. It was long behind us. So we said the value of the product, of the database that we have built is so much that selling a social network didn't make any sense, and you cannot really make a lot of money on social networks unless if you are Facebook, right? So there came the database, and so I'll be getting to the benefits of what all it offers. So what is Blobcity? Blobcity is a next generation database. It is no query. Okay? So what I'll be talking about is what benefits do you get with the change in architecture is something that everyone should adopt, right? See the performance benefits that come when you actually architect your system differently, reduce the number of connection points. So it's not just a takeaway from what we are doing. What I'm giving is what we have done as an example of what you can use in many places. You know, like reducing the connect, we usually have many blocks and all those blocks connect together via TCP channels. Knowingly or unknowingly, we have a lot of TCP channels going through. Okay, and what I'll be giving you today is some insights on what performance benefits your apps can get if you remove those channels. Okay. So, So we did a standard test on our database. This was only on our database alone. And just for the heck of it, I'll call it yes query. Okay. So one is no query, other is yes query. So the way no query works is basically we inject EJBs into your application platform. Okay. Now they are not remote EJBs. Anyone familiar with Java EE? No? Okay, so there's a concept of remote EJBs, enterprise Java beans, and local EJBs, local enterprise Java beans. So the way remote EJBs work is you are using an RMI, remote method invocation. Anyone heard of it? No? Yeah, few have heard remote method invocation, you know that. So remote EJBs work on RMI. RMI internally uses TCP channels. Okay, so that wasn't the way to go. So we didn't want RMI, so we had to be sure that our EJBs iterate within the platform. So we actually use local EJBs. So what you will see now is the difference in performance that you get, right, with using remote EJBs and local EJBs. So when you have your platform supporting direct interaction with other items like a database or any other server processing server that you would have, what benefits you get? So we got 600 ops per second as maximum throughput on a single node. Okay, this is on a single node, multi-threaded environment. We run the test, we run a load test on maximum throughput to see what maximum number of operations per second can the database do. And when we ran it over RMI with remote EJBs, we got 600 ops per second. Here is the difference. Okay? When we run this with no query, exactly same database, exactly same environment, same server, same loading conditions. Nothing changed, just the TCP channel was removed. This is what you get. Tremendous gain in performance. 233% rise, 2000 ops per second. For doing what? Just removing a TCP channel in one layer of the application. If you do this in hundreds of layers that you have, imagine what performance boost you will get. Now we also rated the database, so we got encouraged, we thought, see, we're giving so many additional ops per second compared to our yes query itself, we're giving so many ops per second. So why not see what performance you actually get in general compared to existing databases in the market? Fair enough, right? You want to see now what's the benefit to the whole industry because of doing something that's no query, right? If you look at that, then we ran a load test. Anyone from Mongo here? I'm sure there's someone attending from Mongo. No offenses. I like your database. Okay, this is official stats. The stats were generated. So these stats are actually generated on the Yahoo Cloud Server Benchmarking Tool, YCSP. It was all generated on a 100 million record set. A single table having 10 columns, with one column being the primary key, and other 9 columns were all random binary data generated by the tool itself. Okay? So all the load testing was done on a single Mac mini server. Okay, we actually ship Mac mini servers, and the reason we chose Mac is because HFS plus file system kind of complements the indexing algorithm we use, and Apple sells the HFS plus. So that's the reason we have been doing all our tests on Mac, and we also encourage people to use our database over Mac. There's no restriction, you get slight performance gain if it's Mac against Linux or Windows. So when we ran this test on a 100 million data set, right, and it was read-only because the database is usually optimized for read-only operations. Okay, when we ran it, we got MongoDB and Cassandra almost at the same level. There was noise that was in the test, so when we ran the test multiple times, sometimes Mongo would shoot up, sometimes Cassandra would shoot up. So we have basically kept them both at the same level, around 100 ops per second, a little bit plus minus. Okay. Then we tried on the same server, same config, same data size, everything same. Okay, same tool. This is unbelievable. This is what NoQuery gives. (1,400% rise in performance for read operations. Imagine if your applications could do 1,400% more ops per second. Okay, today, what performance benefit could you actually get? You know the difference between the two? One uses TCP, the other does not use TCP. Okay? Now you will say, in one case with just TCP and no TCP, I got a 233% rise, right? But over here, I get 1,400% rise when I actually do a load test, right? Why so much difference? There is a reason, okay? There is a big reason for this. Let's consider your application in the database, right? When your application basically fires a query on the database, and let's say it's a big data query, right? So you are picking up a data set that's, say, merely 100 MB in size, very common, right, for most big data applications. The result set is 100 MB in size. What will happen is your application, your database will first pick up 100 MB of data, marshal it, unmarshal it over the TCP channel, right, and transport it to the other end, and at the other end of the application, you will again consume 100 MB of virtual memory. You agree? Because you need the data to be marshaled at one end and unmarshaled at another end. Right? That's like marshalling and unmarshalling is transporting data across TCP. So one is like an encryption, the other is like a decryption. Right? So you need to transport it into a particular format and then convert it back into the original format. Let's say if you're running this whole thing on the same machine, for a query that requires a 100 MB response, you would actually consume 200 MB of virtual memory. Right? Doesn't make sense. Now you load up the system. Okay. Mics are also off. So when you actually load this on the same machine, right? You all can hear me?
Yes.
So when you load this on the same machine, you are consuming dual amount of memory, virtual memory on the same physical device, right? Now you run this for like 100 threads, 500 threads, 1,000 threads, right? This is the way we did the test. Then at that minute you will see that the machine actually starts wearing out because you're consuming more amount, you're creating more data, processing more data to marshal it, unmarshal it continuously. You know, something that you would have not imagined, but there's so much processing that happens in encrypting and decrypting, not encryption, marshalling and unmarshalling, right? That your systems don't perform. When you remove this, is the way we have done, you use local EJPs, what happens is you are actually transferring memory pointers to your application. So when the database has picked up a 100 MB response set, it just simply transfers the memory pointer to your app. It never transfers the data. Right? And because of this, the systems are working better, they're loaded less, you can perform more ops per second, and the general gain in performance is tremendous. Right? Something that we in the industry should have actually thought long back, you know, that why do we keep adding TCP channels between layers of applications? Of course, it's for the purpose of interoperability between platforms, right? But it still is a tremendous performance loss. So once you have chosen a platform, it's kind of important to make sure you don't use TCP channels in between them to gain performance. How do we do this? Wait.
I'm extremely sorry, there's some partners.
Till then, if anybody has questions, please.
Yeah, you can ask questions to them.
Shoot it.
Any questions yet? Power's back.
So, you know, and I think you have to go through a representation, right? But you spoke of the benefits. I'm trying to think about if it comes at a cost. And specifically, you are integrating your database application, right? So, that integration, are there any cons to that?
Not really. Alright, because it's a Java E, so and we are using enterprise Java beans. So they are by default cluster compliant, they are thread safe, and they give you, it's automatically managed thread pools. You have an object pool which is managed by the container itself, which is how you would basically deploy enterprise grade applications today. You know, so you're allowing the database to be a part of the app and run similar to the app with all clustering capabilities possible.
What if another app wants to use the same way?
That's fine. It will basically, you are replicating the database. So there are multiple layers here. So one is a clustering layer, which obviously uses TCP. Right? It's something you cannot do, is something that the web server itself will use TCP for cluster syncing. Correct? Just that the app and the database, the channel between the app and the database is removed. Okay? So you can't remove all TCPs because once you talk about clustering, you have to have TCP to sync between nodes. Right? So that is always there, and that's going to work exactly the same way it's working in existing systems. Right? But yeah.
So you say that the application and the database have to be in the same system all the time?
Application, basically the platform, let me say this, okay? Can you host on a Java platform and say Java resides somewhere else?
So
Not possible.
no, the application and the databases has to be in the same system or the application is there on the
No, it's the platform itself. Platform has the database integrated. So when you host on a custom platform, data storage is integrated with the platform. The actual data on the disk in large minutes. That doesn't matter. But the platform itself has data storage capabilities.
So this is a platform or this is just a database?
It's a platform with the database merged. Okay, so it's a fully Java E compliant web container, full profile. Okay, we are using it off open source Glassfish server. It can be used off any other web server that Java supports. And the database is integrated into the platform. So that's the revolutionary. You know, is
The database is integrated into a platform. So what you said the platform is not a database.
it's a combination of both. So we sell the database as a yes-query combination for applications who want to use it, you know, directly because we have other benefits into it which I've been discussing. The other is mainly it goes through the platform. So you take our platform and we post on a platform and have the database.
No query is a platform, not in the database.
Yes, no query is a concept on the platform. The database itself is usable over anything interoperable with other platforms. But if you're using it from something like .NET, it isn't possible to do no query. Okay, so there you cannot do no query. It has to go through normal TCP channels and it will work like a normal database. But yet there is a performance gain. So, should we proceed and leave the questions for the last? Okay, some of the other features, okay, that we give, which actually makes a database stand out amongst the ones that are already there, is something I'm sure all of you have needed today, right? I said we are giving an SQL database with tremendous capabilities of NoSQL, right? No compromise on SQL features, right? That's what I'm talking about. First thing is we give superior indexing, right? Which other SQL databases also give. But when you load them up with millions and billions of records, you will know that the databases don't perform, correct? Now the trick is the way we are storing data, and thank you to the HFS plus file system that Mac offers, we are able to give you fixed time insert rates, fixed time updates, fixed time removals, deletions from the database, and we are able to give you fixed time insert fetches. Bold claim, right? Bold claim. But it does work. When you load the data from the database over an indexed operation, let's say you do a search and a search, or the database picks up the record in under milliseconds. Okay? And then to populate a 100 MB data set and to return it, it will take time. But we got a revolutionary concept of streamed responses. So we don't pick up the whole data set in advance. We kind of start streaming from the first record that we get. Okay, so if you are to pick up, if your data set matches 10,000 records, you will get your first record in fixed time. All records will keep coming in. As a stream, it works as a data stream. So you don't have to wait for responses to come. You can start rendering the client side, the client browser. You can actually start rendering it with the partial data you get, right? And keep pushing it up. This is something that existing databases don't support. Anyone knows of a database that supports streamed operations? Anyone who doesn't know? Okay. Go to a NoSQL database. Tell me if any database supports triggers. Okay. So what is triggering? Triggering is basically a function block present within the database, something like a stored procedure, right? Which the database invokes when data gets mutated. Okay, data gets mutated. Important. So when you run something like a select, it won't run the trigger. When you update a record, you insert a record, you delete a record. Okay, a trigger is called. That trigger, now what's the benefit of this? You can actually write complex business logic in this trigger. It's simple Java code. Okay. Now comes the best part. You can use a trigger to write relations. Insert in table 1, enforce and insert in table 2 with some XYZ logic. Make sense? Allow the database to take care of data integrity. Okay, it's always ensured. Trigger executions are transacted. If any one block or trigger fails, it will roll back the whole transaction. So the relations you could actually build on an SQL database, you can build on a database like ours, because you can write code within the database like stored procedures. Do you know of any NoSQL database today that can take stored procedures? Anyone? Anyone who does not know, can you know query? No SQL database that doesn't take stored procedures? Yes, I'm one of them. If you talk about filters, filters are basically scan jobs, where you can scan through the database, they scan operations, search operations, basically select only, no inserts, no updates, select only. And filter again is code that can be written into the database itself. Okay? And that's complex business logic that goes within the database to pick up data depending on your complex search criteria. Filters take external parameters from adapters, okay, and search through the database in a complex fashion anything you want, right, and then returns the response. So your applications don't really have to pick up all the data, process it, dump the data that you don't want, and then only use what you want. That's what you do with most NoSQL. Right? With SQL, that's not the case. You will actually write stored procedures to do most of these things. Right? This is something we offer. So you can actually write code within the database, have the database improve its performance because the data remains within the database, never comes back to the app. Right? Until it satisfies all the search criteria that you have provided. Right? Tremendous performance. Plus, the database supports, it has full support for transactions. So you can begin a transaction, you can end a transaction, works normally. There's a slight difference. Transactions on normal databases work on connections. So when you open a connection, you begin transaction on that connection. When you close the connection, you end a transaction on that connection. Right? We said, again, this doesn't make sense. Today, you are in a mobile world, right? A single user is having 3 to 4 devices, right? I can basically be playing one game on my computer, and my mom comes in and says, you know what, Sanket, we got to leave, but I'm in the middle of the game. What I will do, I will just say, transfer the game to my iPad, please, instantly. It's transacted. You cannot do this with a normal database. Lobcity generates a transaction ID for every transaction you begin. You can begin the transaction on one node and end it on another node. Okay, it's something that's not possible because the transactions are not bound to connections. Why? Because we don't have any connections. Right? There is no TCP, we don't have any connections. When you begin a transaction, you begin from one node, you can actually end it from another node. It fails on another node, it will roll back node 1. Okay? It's a complete new revolution. This is not technology that is available in the industry today. It's not something we've seen. It's a full new generation. Opens several possibilities that you cannot even think of right now. You start using it in your app. So coming to the last part of the presentation, the key benefits is there's no latency overhead because there are no TCPs, right? Reduce failure probability, right? Why so? Simply because I have lesser blocks in my application layer, right? So if I have a database running and I have an app running, and both running together, there's a high probability of failure of one and not the other, right? But if I have everything integrated into the platform, then it's either if my platform fails, so does my app, so does my database, right? Or my platform doesn't fail at all because I have high availability, I have clustering capabilities, everything, right? So it's less probability of failure. Failure, everything fails, otherwise nothing fails. You don't have modules failing, right? Then you have more throughput because of the no query. You can actually get more throughput because you've reduced the latency. So the point 1 and the point 2 are almost the same. So no latency gives you more throughput. Fixed time insert, select, update, and delete is something that we give, right? If you compare Blobcity with any other NoSQL or SQL database, Blobcity will not perform at all if you're talking about a few thousand records. Okay? When we give fixed time inserts, it is at a compromise, and the compromise is the initial set of the curve is not high performing. When you go to a billion records, okay, that's when you will see that all other databases, the curve goes up, right? Because they're not fixed time inserts, they're not fixed time updates. Our database will go flat. If you got to use it for something that is of a small data size, this is not, no query is not the thing, in general. If you want to use it for really high performance systems, where you have huge data sizes, which is why everyone is here today, okay? And you will see that when you go to a billion records, Blobcity gives a flat curve. They give you the same insert time as the first record. A billion record insert will take the same time as the first record. Schema change support. It's a big nightmare. Okay, it's absolutely a big nightmare. You use HBase, right? I have a Facebook article that reads that when Facebook requires 2 columns in a table, one primary key, other is one more column, just to store some random data, right? They create 50 columns in that table. Why? Because HBase cannot make schema change operations. So in future, if I want to add a column into the table, that's it. I cannot do it, right? Which is the case with many NoSQL databases as well. Schema changes are not fully supported. Okay? We said we have to remove this. This is not something that you can work with. It's not something that you can live with. You are saying, I need to do a business requirement analysis for the next 10 years today, anticipating what columns I will get tomorrow, today. It's just not possible. That's like saying writing perfect code at the first shot which runs without debugging in the first run. It just doesn't work that way. Right? So you've got to have changes. And this supports all the changes that any SQL database really can support. Anything, changing data type, changing column names, adding columns, removing columns. Brilliant question that somebody can ask here is, if I have to add a column, basically add is simple. If I have to remove a column from a data set that's a billion records, how much time will it take? Right? Instant, milliseconds. Because every schema change in Blobcity is actually a soft change. It's not a hard change. It doesn't apply to all records, but when you pick up the record, it ensures that the schema change is enforced on the record. What most databases and what most SQL databases also do in advance when you run a schema change, Blobcity does at runtime. Because we've got huge data, you cannot really, every time you change a data type, you cannot wait for the next 1 week for the schema change to apply on a billion records. It's just not going to happen, right? It happens in milliseconds. It's all soft changes. Triggers give you the ability to recreate scenarios that you could actually handle with SQL databases efficiently, creating relations, putting complex business logics into the application, right? And filters into scan jobs, like really good searches, without actually loading the database data in memory and then having the application process. Your whole application search logic can actually go within the database. Okay? So these are the few things that I had to talk about. And that's it, so you can always write to me. You have my brochures, and my brochures have my business card attached. Okay, so you can get in touch with me anytime you want. And we are open. Do we have time for questions? Okay, any more questions? Feel free to bombard. I'm saying so many things. It's all bold claims here. Feel free to bombard.
Does it also have the features like what enterprise class database offers, for example, partitions, high availability, backups, recoveries, and all those?
Yes, absolutely. Absolutely. You can do data sharding. You can keep backup nodes separate. You can keep its cluster ready. So if you buy a hardware and you can just plug in devices, there is no conflict. Absolutely no conflict. Just connect it to the network, hit the power button, it will immediately start clustering. So it's instant scalability, almost near infinite scalability. Okay, so to the extent that we have tried, we have never seen any scalability issue. Okay, and it supports everything that your enterprise application will support.
So what kind, this database is suitable for what kind of applications?
If you have purely use
Can I use, for example, for my traditional applications, can be my enterprise, let's say banking, web development?
Absolutely. Yes, absolutely. Quite a few of our clients today who have anticipated big needs, have used this database even for small applications. Okay, it gives you very, very decent performance and good performance. Not as fast as SQL, but then if you have just a few thousand records, you don't really care whether my query runs in 1 millisecond or 5 milliseconds. Right? That's the only marginal difference. But it works. So most of our clients today, what they've done is they've actually started adopting this database, started putting in the data because they anticipate that the data will grow to 1 billion records tomorrow. They've kept it on a reliable database today itself. So it can be used for all wide range of applications. Any more questions? Frankly speaking, we have not done a full comparison with something like that. But the beauty is the database can actually, we give full RESTful APIs. Okay, so you can integrate the database into any platform that you want. So there is no limitation as such. But comparing with SAP and HANA is something that we have not really done. So I can't, give you some performance measures. But you can basically plug it in.
I just wanted to understand how easy it is to migrate existing application. Like suppose someone is running 3-tier architecture and now wants to move to this database. So how easy the adaptability and migration?
It's very easy. It's very easy. And to make your life simple, can I put it this way? You just need to give us your database and do all the migration. Okay? There is usually no code change required. Code change, basically you plug in an adapter into your existing system, keep it the way it is. If you're firing SQL queries, keep it, let it fire SQL queries. Just plug in an adapter, okay? We will port the data from any database that you have today to our database. Any application will run, no code changes in your app. And then eventually you can change it to get better performance.
So, but the benefit they will start getting from the start during the...
Yes, absolutely. Absolutely. Because you will get indexing, you will get trigger support, you will get filter support. You will get transaction support, which many of the NoSQL don't support. So you're benefited by all these things, plus the database is a fixed time for index searches. It's absolutely unachievable for other databases, fixed time search.
So what is the benchmark for the fixed time, like billions of records? You are saying that it will take the same time?
Yes, absolutely. The data starts streaming at the same time. If you have, let me put it this way, if your search matches only one record, right, the time you run it on a data set that has only one, database that has only one record in it, and you pick up only one record, it will come instantly in like microseconds kind of thing. If you have a database in a billion records, with a billion records, same database, same server, everything same, and you fire the same search query, the search query matches a single record, right? The criteria matches just for a single record, you will still get it the same microseconds. But if your search query matches 100 records, then you will need 100 microseconds. Fair enough, right? But we start streaming from the first microsecond.
In the background, everything is RESTful API.
No, RESTful is for compatibility with other apps.
Okay.
You know, so from other platforms, if you're using Java, I wouldn't advise RESTful, just, you know, integrate together. And RESTful is for extensibility, so you can actually use it from any platform.
Thank you.
Usually, it is said that big data uses NoSQL or unstructured database, so to speak, which primarily gives importance to performance rather than security. But as far as this architecture is concerned, how about security? Another question is, can we have any kind of VAPT or any vulnerable access line or penetration test or some such frameworks or standards which can evaluate the security part or the databases?
Yes, absolutely. You can run the test. So there are two ways. One is you put the data on the cloud, in which case a cloud system needs to be certified for all the security tests that you need. Other is you can actually take this and put it in your premises. So when it is in your premises, you secure it the way you want, right? And that's completely up to you. Because the first security will come from securing the server itself, right? And then securing your application against hacks. But if the server is secure enough, you don't really need to secure your databases.
You would say that kind of combination will work. Right?
Yes, absolutely.
The application will be on the web, on the big data area, and the database will be residing locally.
Yes, absolutely.
Thank you.
Any more questions? Okay. The mic is for others.
So, just one quick question. You basically talk about improved performance with respect to what you're doing by removing the transportation layer and all that kind of stuff, right? I mean, do you use an additional improvement in performance by doing processing of data in memory? Do you have any models for that?
Yes, it's actually a proprietary algorithm that uses in-memory processing as well as specific format of storing data. So we support B-tree indexes, unique indexes, so unique hash indexes. We support all of that, but the B-tree is still stored in a proprietary format on the actual file system, which allows us for fixed time reads. B-trees are known for fast reads, but they're not fixed time. But we actually split the trees into basically create multiple trees, something of that sort, and to make sure that the reads are fixed time. In search, index searches are fixed time. So it's all proprietary technology, including in-memory operations, so making use of the net memory that you have available. But in general, when we ran tests on 100 million records, okay, the database, when we showed the performance difference of 1,400% rise, okay, most of Cassandra and Mongo actually used RAM. Our database just used a few MBs of RAM. Okay, so it's more on how we store the data rather than how we process it. But it makes use of memory when available to actually increase your performance.
Have you done some specific benchmarks on ONTP or OLAP kind of database?
Not really. No. You see, I tell you, we've done a benchmark with a lot of databases. Okay, so obviously it wasn't possible to share everything here. So anyone who wants the complete white sheets and the steps to reproduce the results can actually write to me and I can send you the whole white sheets. And if you need any specific database that you want it rated on, which we have not already done, we can actually do that. Give you a performance comparison.
Does it work better with analog or digital?
Even though I'm saying that the data is structured, it's actually still unstructured. Okay, so you can use it with digital data or analog data. So analog, you mean something coming from sensors and everything of that sort, right? Right? Absolutely possible. In fact, to give an example, I would actually say you can keep analog data in the database, write a filter to get all data points, if it's a sine wave, get all data points that have a phase shift of 90 degrees. You know, and that logic goes into the database, not in an app. You know, it actually goes into the database. It gives you tremendous performance. Okay, so if you have any more questions, we have a stores, you can actually come and meet us. Okay, and you're encouraged to ask any questions possible. So I'll hand it over to the organizers. Thank you very much for listening to me.
Thanks a lot, Sanjay, for the very good discussion and a very good Q&A.